Hello, welcome to Program with Sam, and welcome to Python Lesson 5. Okay, so the last thing we're going to cover in this series is going to be data visualization in Python. So today we're going to be taking a look at a couple of the graphing tools that are available. Now, when it comes to visualizing data, there are two main sort of packages or libraries that you'll be using, and those are Matplotlib and Seabourn. They offer sort of like a different set of features, but those features are very similar, and there are advantages and disadvantages for each package, and ultimately it will generally fall under sort of A, your personal preference, and B, the actual objective that you're trying to do, like what you're trying to achieve is going to determine which library that you're going to end up using in the end. Now, Matplotlib offers tools for the majority of your basic graphs, sort of bar plots, line graphs, etc., etc. But Seabourn has more of a statistical focus. So a lot of the visualization that you do through Seabourn tends to be more stats based and statistical visualization of data. So like in addition to this, it's also going to depend on the manner in which you've stored your data within the application. So one thing you've got to bear in mind is that Matplotlib is very well integrated with NumPy arrays and pandas data frames, whereas Seabourn is more integrated with pandas data frames and less so the NumPy arrays. So it might be that if you're working solely with data frames and that's all you want to do, it might be the case that just working with Seabourn is the way forward. That being said, pandas data frames actually have like a pretty good wrapper for Matplotlib graphs, which is what allows pandas to generate their graphs essentially. It's quite a nice way of working. In terms of flexibility, Matplotlib is going to offer you more than Seabourn, because Seabourn removes a lot of sort of like the boilerplate style bits and gives you very powerful generic templates for graphs that you can then apply your own data to, whereas in Matplotlib you're given near enough full customization of the actual figure, including subplots as well. So that's another factor that you should take into account, is how flexible and customizable the actual libraries are. So what we're going to do now is we're going to take a little look at some charts that we can plot using Matplotlib, and then we'll also do some Seabourn ones as well. So let's have a look at some of the plots available to us in Matplotlib. I've gone ahead and gotten us started with the random module, the NumPy module, and the matplotlib.pyplot, and we're importing it as PLT so that we have access to the plotting functions. I've also just generated some arbitrary data points that we can then actually use to plot and just mess around with the plots. So one of the plots is obviously one of the bog standard ones is a line chart, and in fact that is just data.plot or plt.plot, and then you put the data in. So if we run that, it generates a line chart. If we do plt dot subplot, dot hist, and then pass it the data, we can create a histogram, although that's overlaying it onto the same one. So if we do plt dot subplot, that didn't work. It's because we need to set up a figure. But what I can do is I can just Control X that, Control paste it in there. Boom, line graph, histogram, completely separate things. You can do things like imshow if you have an image that you want to display in the actual document. You can do color meshes, and in fact I have something here where we use a color mesh. If we just scroll down through here, not this one, in here. So this is an example of the imshow and subplotting. You have these images are being shown on the subplots here. And then if we scroll down, I'm pretty sure there's color meshes at the very bottom down here. Yeah. So this is a color mesh. So based on the value of the array, that's the value that comes out. So we might actually be able to do that with we'll see. It could go either way with this data, because obviously it's not exactly yeah, I didn't think that would work. Not enough values to unpack. Yeah, because it's not two-dimensional, is it? That's why. But there are a lot of things that you can do with Matplotlib. You can even do 3D plots, streamline plots, bar charts. So bar charts is another classic one. So blt.bar and then data, and then it's missing the height variable. 10. I mean, obviously you cannot draw any meaningful information from that. Let's try 30 and see. It's probably because, yeah, it's because the box is so small. The actual figure is just tiny. But yeah, you get the idea. There's lots and lots of different things you can plot. Pie charts, plt.pie, and give it the data. Oof. Obviously, again, because it's such stupid arbitrary data, looks a bit weird, but it's just an example of the different plots that you can do. plt.scatter is another good option. If we run that, missing argument y. Y is equal to I in range I is not defined. X for X, there we go. Well, they must be the same size. So let's say 251. There we go, perfect. And that's a scatter plot. There are so many things that you can do with Matplotlib. And ultimately, it is entirely dependent on what you want to do. They have a lot more parameters that you can put in to fully customize your charts, including changing the color, adding legends, adding more and more plots to it. There's plenty of things that you can do with Matplotlib, a lot of customizability, and ultimately the way in which you use it will boil down to what specific functions you are after. Okay, so Seabourn is an alternative to Matplotlib, as we've discussed, and it has a multitude of features available to it as well. To demonstrate Seabourn's uses, I sort of imported pandas and Seabourn, and I've also read in a data file that I had just in my downloads. I think we used it for the R practical, I can't remember, but either way it's in my downloads for some reason. And this is what the data frame looks like when it's read in. Obviously, if you don't know how to read a data frame in, you can go back and have a look at the tutorial we did on NumPys and pandas, and that will cover everything that you need to know. So let's get into some Seabourn plotting. So one of the things you can do is a scatter plot. So what we can do is we can say sns.lmplot, and we can say that we want to plot different columns against one another. So we could do volatile underscore acidity against, maybe the Y could be citric acid. And then the data that we're going to be using is going to be df. So if we then run that, it should then create our plot there. And you can see it's tried to do a line of best fit by the looks of it as well. And obviously it doesn't really seem to make much of a difference. But we'll let it believe what it wants to do. So there are other plots as well that we can make. For instance, we can like stop the line of best fit, the regression line, by just sort of using a hyperparameter, or a parameter rather, which is fitting the regression, and we can just say that we don't want it. And then if we do that, that's just the data as is then, which is a lot more appealing to look at, I think. We can also do stuff like box plots, because obviously, as we said earlier, it's more statistical based, Seabourn, than Matplotlib. And the reason why that might be beneficial is for things like this, if you want to see the distribution of the attributes. So if we do that, we can see here that the attributes are distributed in different ways with outliers and so on and so forth. There's plenty of things that you can do with Seabourn that potentially you wouldn't do with Matplotlib. You can even change the style with Seabourn. That's one of the things, is that whilst you do not have complete customizability, you have quite a lot of presets that are very visually appealing and good to look at. For instance, and perhaps another plot we could do is a violin plot, perhaps. So if we do violin plot, and maybe we want to compare another two attributes or another two columns. We can do alcohol versus pH, and then the data is going to be data frame. If we plot that, we get our violin plot. Like there is a lot of things that we can do with Seabourn that perhaps we wouldn't do with Matplotlib. For another one, for example, is a swarm plot, and we can, in fact, we can just copy this, and it's basically the same information, just displayed in a different format. Swarm plot, run, and that's the swarm plot. I mean, Seabourn also offers the ability for you to overlay the plots as well. And in fact, I'm pretty sure you can use some Matplotlib elements to customize the Seabourn plots. I do wonder whether it's possible to do subplots. So can we do plt.subplot? If we say 3, 2, 1, and then if we put this in there, does that then work? It does. So what you can do is you can even use some Matplotlib functionality to essentially improve the Seabourn plots and make them look just better, really. Just improve how they go into your documents and how they go into your code. So what I will do is I will condense all of those into a subplot of the plots that we've made, and then that will all go on the GitHub. And that is it for Python. We're completely done with that now. I don't want to touch any more or do any more with Python on the channel, at least not in a tutorial like this format. I hope you found it useful. I hope you've sort of gathered the basics that you need to go out and start doing stuff in Python. There's a plethora of tutorials that take you into more advanced stuff out there, and I actively encourage you to go and watch them and support other creators. Thank you for watching if you made it all the way through, and I will see you in the next series. Bye.